So find entropy change when air undergoes a process from pressure P1, temperature T. So pressure P, temperature is a repeated question already. We have solved this question number 18. So look at question number 19. 1 kg of ideal gas having Cp, so 1000 joules per kg Kelvin, and pressure 1 bar, temperature 300 Kelvin, was sealed in a rigid cylinder. So the work done on the system adiabatically by a stirrer. A stirrer work is given as 100 kilojoules. So what is increase in entropy of the system? So he is saying that there is a rigid container. There is a rigid container. Well, I said something is rigid, so its volume will not change. So since its volume is not changing, there won't be any boundary work. So the only possible way I can do work on the gas present inside the cylinder or container, rigid container, is by a stirrer. To take a stirrer, just to rotate the stirrer. So that's the only possible way by which I can do the work. Okay. So he's saying that it's an adiabatic work. So I can say this rigid container is insulated. So no heat transfer from the rigid container. So there is a stirrer. So and he's rotating the stirrer. So by rotating the stirrer, so he's giving some work input. The work input that is given to the air is 100 kilojoules. 100 kilojoules. So what are the work that is given to the air? So that will be dissipated into air, and all the work is converted into heat energy, and thereby temperature of air increases. So he gave initial pressure of air is 1 bar. Initial pressure is 1 bar. Initial temperature is given as 300 Kelvin. So initial state is given. So when I do some work, so temperature increases. When temperature increases, both pressure and temperature increases. So now the pressure is more and temperature is also more. Why? Because pressure increases, because volume of the container is constant, it's fixed. So mass of the gas inside the tank is given as 1 kg. And he's asking us to get the value of change in entropy during this process. In this process, work is converted into heat energy. I can say available energy is, I can say high grade energy is converted into low grade energy. I can say unavailable energy increased during this process. I can say entropy increases during this process. So he is asking us to get that change in entropy during this process. So I can write like this. So change in entropy for an ideal gas. So from TDS equations, so TDS is equals to, so du plus PdV. So if I integrate this one, so I will get Cv into log, so T2 by T1, so minus, sorry, plus R log, so V2 by V1. So here if you look at the container, it's a rigid container. For a rigid container, there won't be any change in volume. So initial volume and final volume remains same. So delta V is 0. I can say log 1 is 0. So I can say change in entropy during the process is a Cv log, so T2 by T1. So he gave Cv is given as 1000 joule per kg Kelvin. So log of, so final temperature T2, so divided by initial temperature is 300. So if you know the final temperature, you can get the value of change in entropy during the process. Now how to get this final temperature? So whatever the work you are supplying to the gas is converted into, so heat energy. I can say it's used for increasing its temperature. So I can say the energy supplied is this one as work, that's converted into heat energy. It's used for increasing its temperature. So increase in temperature is mc delta T. So I can say, so delta T is, so 100 into, so 10 power 3, so mass is 1 kg, C is 1000 joules per kg Kelvin. So if you simplify this, so you will get delta T is 100. So delta T is nothing but T2 minus T1, so T2 minus T1 is 300 is 100. I can say the value of T2 is 400 Kelvin. So final temperature is 400 Kelvin, T2 is 400 Kelvin. So change in entropy of the gas is 1000 log 4 by 3. If you simplify this, (287.68) joules per kg. Mass is 1, you multiply with mass, you will get joule per Kelvin. So mass is 1 kg by the way. So joule per Kelvin and joule per kg Kelvin both are same in this case.